Welcome to my presentation on optimization in enterprise AI solutions as part of the combinatorial optimization at work workshop 2020. My name is Oliver Bastert and I'm heading up the optimization product management at FICO. I want to broaden the perspective from optimization to AI solutions and even further to enterprise AI solutions. So what are the components I need to build full end-to-end solutions and deploy them in use for enterprises? First, what I should do is I should probably define what I mean by an enterprise AI solution. The next step is then I will talk you through the FICO Express products with a little bit of a view on history and our current capabilities. And then in the second half, I will focus on a variety of use cases, some specific features we provide, and then finish off with just a number of pointers for you if you're interested in what you saw, so you can go and follow up and use our software yourself. So that's kind of like the outline of my presentation. First, what do I mean by an AI solution? And that's not only my personal perspective, but that's an established industry view on what comprises an AI solution. So first off, every solution in our field starts with data, which you need to feed into our solution. And then once you've done something to that data, you will feed results back. And that's the learning loop, improvement loop, execution loop, however you want to call that, or what specific use case you have in mind. But that's always a very important and critical part of such an AI solution. Historically, the first thing you probably think about is you want to apply some computational logic. And in terms of an AI solution, we think about decision models, business rules, might be policies, regulations, just some way of expressing your model in business rules. Then with the actual logic or your computational capability, you also often have very specific UIs or interactions methods, like you want to check expected versus actual performance of your rules. You might want to monitor behavior. So this is typical application capabilities you have when you're dealing with computational logic or decision models in particular. The next big building block is probabilistic reasoning. And I think this is what most people understand with AI, or what they consider AI to be. Classical predictive model, machining, machine learning, deep learning, reinforcement learning, you name it. And an area which clearly becomes more and more important is explainable AI or interpretable machine learning models. So why do I get a certain result out of my method? And I will briefly touch on this later again. And the third pillar of such an AI solution is, guess what, optimization as well. Could be linear, nonlinear programming, extended or constraint programming, might be any other optimization technique. I'm obviously focusing on mathematical optimization here, so this is why I stress those techniques. But when you're dealing with optimization, core parts of a solution you build around optimization techniques is capabilities like scenario analysis, simulation, stress testing. So the whole infrastructure you need around your pure solver technology and optimization model. So in this frame, I want to think about AI solutions and what you need to create and deploy those solutions in enterprises. Then a little bit on myself. So my background is in mathematics. I then became a mixed integer programming developer in the Express product team. And after a while, 10 years ago now, I moved into product management. Product management comprises basically of everything around a software product, in my case, or an offering, if you will, from very strategic considerations like what product should I build, what product does the market need, throughout all the way working with development, creating those products, and then finally going into execution, so delivering it to customers and supporting existing products. And my role also goes quite a bit from very business related or non-technical items like pricing, contracting, to very technical duties like still discussing certain roadmap items with our solver team or our technical teams we have in FICO. So that's what I do. If you want to know more about what I'm doing, the link I'm providing here is a pretty good overview if you want to learn more about product management. Okay, with this, I want to get started on a little history of Express. And it all started in 1983. And the really cool thing about Express was from day one, we looked at mathematical optimization solvers. So in 1983, we had the first ever LP solver running on a PC. Yeah, so 83 was also the year where the PC was really invented. So that's our starting point. But we combined this immediately with a modeling layer. Yeah? And in my view, it's really important to have a high performance solver. And it's equally and probably even more important to have a model which actually is well formulated and hence solvable by a solver. And the best thing you can do is you have a model which plays to a strength of the solvers you've selected. So combining those two into one product was the starting point. And in 86, we introduced the MIP solver. Yeah, so this was the start of our mixed integer programming solver in 86. Then fast forward to this century or this millennium, we then added a new modeling language called Moselle, because we figured, yes, you need to be able to algebraically formulate your optimization model. But what you're also doing most of the time, you need some programming to go with it. Like you want to do some pre-processing, you might want to implement a cutting plane algorithm. And with Moselle, we are allowing those two things to happen in one integrated environment. And then also we added the ability to develop those models, interact with the solver with an integrated IDE in 2004. So that then comprised of a great developer experience combined with high performance solvers. The next thing we looked at was, okay, now we have these models, we have those solvers, we can develop our models, but the results we are still presenting in PowerPoints, or people have to hook up other tools to present results and interact with those models and solutions. So we started developing a visual and collaborative environment to deploy those models into the hands of business users. Yeah, so we wanted to broaden the usage of optimization technology beyond the science lab, if you will. And this has been a very successful path since then. And if you just look very briefly on what type of features we are providing, it's like, as I said on my initial slide, it starts with the data. Yeah, so still many legacy users we see, they like Excel, they have file-based data storage. And the first thing you need in an enterprise solution is actually having a proper data management. So we are providing this. Then you need to be able to look at your data, profile your data, or even look at some impact when you make a decision based on your data. So this is critical to provide. The next step is then, so I have everything set up, and then I want to start running what if analysis. So I'm changing certain parameters, certain data points. I'm increasing my production line by another machine. I'm buying a few trucks, or I assume there's heavy traffic in my planning problem. What happens to my solutions and my optimal solutions? Then once I have multiple solutions, I want to do side-by-side comparison by a few or many scenarios. And for that, you need a scenario management capability. You also want to provide the application to various different user personas. So like an analyst, a semi-technical person, or a very high-level manager who just wants to see summary reports. So your applications need to support different perspectives for different users. All of that, we're still doing optimization here. So you need to have access to great mathematical modeling and optimization tools. And as you will see in a bit, we have decided with Express to really support not only linear programming, mixed integer programming, but also nonlinear programming and constraint programming. Yeah, so for many applications, you need more than just very focused solvers. It comes in handy if you have access to all those technologies, and for certain applications, you can combine those technologies to build a full solution. I've alluded to Moselle before, and we are also supporting Python as an equal alternative to Moselle within Insight. So you can really choose, do I like an algebraic modeling language with programming capabilities, or am I really the more programming person who also wants to build mathematical models? So this is an option. Another core piece is the reporting, dashboarding. Yeah, I think that's pretty obvious to everyone. When you want to analyze solutions, when you analyze results, visualization is very helpful, and again makes our results and our technology much more accessible. Then if you're going from few simulations or what if analysis to many, yeah, then we are talking about champion challenger. We're talking creating efficient frontier, doing some scenario-based sensitivity analysis, and this is all supported and really critically needed for those enterprise AI solutions. And then finally, a piece which is often just assumed that it's there, but very hard to build out if you do this on your own, is you want to have user management, you want to have security, you want to probably develop and publish several solutions. You might want to have some governance around the results or the inputs going into that solution. And this obviously comes with it and makes an OR solution a proper enterprise solution. Yeah, so this is how we see at FICO the requirements and needs to deploying optimization models into those decision support applications, which I've described here. And just to give you a little impression here, how it looks like. So we have a modeling environment for describing your model algebraically. Then we have a drag and drop capabilities for creating those UIs. It's a fully collaborative platform to do this. Then it's a single click to deploy what you've just created into the app layer. an app server, and as described before, you have your enterprise-ready advanced analytic application. I haven't focused on this yet, but obviously we can develop and orchestrate not only optimization models, but it could be as well be any analytical models. Since we use Python extensively, we connect to R. You have those capabilities built in for free pretty much. So this is where we are. I described to you the application layer with Insight, the modeling layer with Moselle, the solver layer, still the heart of what we're doing with linear mixed integer, nonlinear and constrained programming solvers. And this all integrated and made accessible via an IDE for developing model solutions and optimization services. Then with FICO, we had the opportunity to take our optimization technology and put this into an integrated decision management platform. So remember, AI solutions are comprised of multiple components like analytic technology, machine learning, as well as rules technology. And on the FICO platform, all those capabilities are provided and consistently integrated to create those more complex and complete AI solutions. And this is how it looks like, yeah? So we discussed data, we touched on the development process of analytical models, and that includes here optimization models as well, so the really broader sense of analytical models. And then you're starting to validate your work, run some simulations, and we see those tasks carried out by analysts, operations research specialists, by data scientists. So this is the one group using our stuff. And then if you look further down the line, you're taking those analytic assets, those solutions, and deploy them either into automated decisioning applications. Yeah, so think of it as basically a headless analytic service, could be optimization running in real time as part of a bigger application, or classically almost I would say as a decision support application. So I'm planning my 75 trucks in my business. And all of this is often combined with additional business rules captured around this. And you will see some of those examples later on. One thing we recently added and really completed the Express offering is to not only support Python APIs, which we do for a long time, and we had integrated Python with Moselle, so there was a tight connection again for a long time, was really to say and enable that it's now an equal partner on the Express platform. So you're now able to build full applications in Python and Moselle. If you're interested in this, there's a blog post describing on a very high level to quickly build your first application. And we have a step-by-step webinar, which I can just recommend. It's really easy to follow. Download our software and try this out and build a Python-based business user-ready optimization application. Then there's a big question, not only around what solver do I need, what solver technology is most suitable for my problems, but we're seeing the same discussions and questions around what's the best way to model my optimization problem at hand. Yeah? And we looked at this in quite a bit of detail around which language is easier to develop in those algebraic formulations, and then also what's easier to read, and contrasted this with the performance implications of using one approach or the other. And I'm summarizing here just very quickly. So we found that an algebraic modeling language like Moselle is still much better to read than a piece of Python code, the algebraic formulation of your Python code. And in performance for optimization models, Moselle, and this is the example language at hand here, is still much higher performance than an Python API. And we use, again, the Express Python API here as a comparison. Whereas if you're going to more generic programming tasks, probably some pre-processing tasks, we can do a lot around tuning Moselle to be close in the performance to Python, but it's also very clear that Python has some advantages for some of those data handling tasks. And now it's up to you to decide based on personal taste, all the way down to what your specific application requirements are. Again, if you're interested in details, follow this link and you will see plenty of discussion points listed there. So this is now a little bit more than a summary of the innovations in the 35 plus. Express is in the business, and it's the not only the longest standing commercial solver, if you will, but it's also the solver and modeling and solution technology which will stick around for long. Started with the first LP solver running on a PC, and then in the 90s, I think that was probably, and because I went to university during that time and started my PhD, so that was obviously for me the most interesting time in our industry, but it was, I think, also objectively pretty interesting. We experimented with parallel and even distributed MIP. Yeah, so there was a distributed Express available in the early 90s. And then to me, still the major breakthrough was to actually make general purpose cutting planes viable in a general mixed integer programming solver. And Express was actually the first solver, the first commercial solver out there to have that included. And from that point onwards, I mean, there were plenty of other innovations, lots of progress. I don't want to diminish this, but from the mid to end 90s, we as an industry were able to reliably solve mixed integer programming problems. You can see lots of other innovations, parallel MIP heuristics, 2010, the ability to solve really large problems, larger than anyone in the industry back then. The first parallel simplex, commercial parallel simplex implementation in 2014, still in our suite. And then important technical innovations as well, like our task-based parallel MIP, which allows you to have deterministic behavior and equal behavior across different size machines of the same type. So no matter if you're running on 2 or 4 or 8 cores, you can set controls to run exact the same search path, as well as across different operating systems if they're based on the same CPU architecture. So again, important for enterprises which often have a development environment which differs from the actual deployment situation. You need to ensure your technology is behaving the very same way. And then what you saw from Timo earlier this week is an example of combining machine learning and optimization with the learning to scale functionality. So this is a constant area of innovation for us, exciting research and development going on. If we look at Moselle and our modeling capabilities, it started all as an algebraic modeling language, yeah, then very quickly became a modeling, solving, and programming language with Moselle. And then we added lots of very important programming features like profiling, debugging, parallelism, distribution. So Moselle is a fantastic environment for building and solving complex models. Moselle is free by now, yeah, so everyone can use it in certain use cases as well as open. So you can attach to it any solver technology you like. We have fully integrated with R and Python, and for performance reasons, we have re-architected Moselle to Moselle 5. So it's an even faster language than in the past. And then on the business user enablement side, I've shown you inside. And again, there's a lot of excitement around this capability. And I showed you the main steps, what we achieved there. So I don't go into more details. I want to refer though to our optimization blog. So there's lots of those innovations, in particular in recent years. We've discussed there. They are for technical users. They should give you some insight on what we're doing and allow you to also make more efficient use of our technology. Okay, with that, I want to switch now to some of the use cases and some examples how you can apply those technologies and how you can combine optimization with analytics and rules technology. Okay. So before I get there, one statement, and that's part of these first couple of use cases I'm going to show you. The world is actually nonlinear. Yeah. So most of us are used to linear mixed integer programming modeling, and that's for several reasons. And I think the two main reasons are the solvers are just fantastic. Yeah, so I can model a linear or mixed integer programming problem, and with a very high likelihood, I will get the result in a reasonable time. And it's also easy to model in linear or mixed integer programming terms. So we know how to model logic. It's a simplistic enough language that many people can use this. If we're going to nonlinear world, the main advantage is we are able to create much more accurate models. Yeah, so really modeling the real world more accurately, and with that coming more accurate solution at the price of more modeling complexity, more modeling knowledge, and obviously the fact that nonlinear problems are much harder to solve than linear or continuous linear problems. So, but still, there's a number of application areas like pricing, portfolio optimization, risk management, blending, general chemical processing. So these are all areas where nonlinear technology is very established to solve those demanding optimization problems. And I wouldn't be a good product manager if I wouldn't highlight what we really include and express here. So we have a number of different nonlinear technologies. And the two to mention here are first order, like nonlinear optimization, successive linear programming to allow for solving really big problems, and then also an interior point method is included in Express. It's fully integrated with the modeling. Yeah, so when you do nonlinear optimization, your modeling tooling becomes much more important. Your derivative calculations become much more or suddenly become important because you don't have that in the linear case at all. So we're providing this, and then we have support for user functions, or some call it black box optimization. So it's a full and interesting offering here. But now let's look at the other side. How do we actually use it, and what are probably some of the challenges we're facing with our customers when they start using this stuff? Okay, so some of you might know FICO. FICO is for some of FICO's business, we are very strong in financial services, more specifically in retail banking. And so some of our customers want to price personal loans, like what's the best interest rate, what's the term we should offer to specific customer segments to make the most profit, limit risk and exposure. Yeah, so these are the questions typically asked. And one important factor going into this is when I offer a loan at a certain interest rate, to make it really simple here, what's the take-up rate by that customer segment. And as you can imagine, if I increase the interest rate for a loan, the take-up rate will decrease. So this is what you're seeing here. And in our ideal scenario, it's a nonlinear, smooth, convex function. You have the choice of linearizing this at the price of losing some accuracy. Yeah. So alternatively, what you could do, you could keep the nonlinear function and solve it with an interior point or a successive linear programming approach, as you can see both depicted here. The challenge is the situation isn't like this. If you look at a realistic take-up rate versus interest rate model, it looks like this. Yeah. So if your competitors in the market, so if your interest rate increases too much, you will see suddenly a significant drop in rate because there's a competitor with a better offering. And it's even worse, actually, because interest rates are not even interest rates are. Yeah. So suddenly your nonlinear solver needs to deal with only partially defined predictive model information here, and still being able to solve the underlying much bigger optimization problem. And we've solved this. So we are really interested in combining mathematical optimization with analytics, and this is one of the challenges we are resolving in Express, as you can see here. Then another example is, now think about deposits. So you have a set of different funds. Again, you want to make offers to your customers, and you're looking at the market from one time period to the next, and depending on what rates you're offering, yeah, and terms around your deposits offerings, you will see a movement from one fund to the other over time. And we're looking just at 2 time periods. And what you're doing now is you're modeling this as a big network with some statistical models describing which fund moves in which quantity to which other fund. So if you look at this in a little bit more detail, you have your funds, and then some kind of model transformation formulas, however you want to look at this, between each of those funds. And you have that for whatever many time periods, 50, 100, you're looking at. So this becomes suddenly a really, really big nonlinear model. Luckily, one of the starting points of Express back in the 80s was in the processing industries, and we've looked into nonlinear technology in this area for long. And if you look at a classical processing industry problem, it's the very same. Yeah, so have some products, you're feeding them into some process, and you're getting out some other products. And in processing industries, we are not having statistical models here, but we very often have simulations, and we are able to optimize over those black box simulations to derive an optimal or near optimal solution for those processes. And I think that's a very neat connection between a financial services problem and a actual process industry phenomenon. And it's not only used in financial services, what we're doing here, but also with large corporations. And one long-time user is Shell, and they're actually using our specific nonlinear technology in all of their more than 600 global plants for real-time process optimization. Since we are in energy, I want to describe one other very important feature of optimization. So yes, it's about modeling your real world problem and then having a solver which can produce a optimal solution. But before you're interested in this optimality, or you're even considering, you have a very valuable piece in that optimization model. It's actually the model of the real world. And in energy or in energy network market modeling, you're using this model with the optimization technology to model your market behavior. So you're interested in what are the energy prices, could be power, could be gas, for energy now, tomorrow. Yeah, because if I can predict the energy prices tomorrow, the power prices, I can probably make some good trades based on those pricing predictions for the day ahead. And that's what energy companies are actually doing. Yeah? So they're building this market model. They're optimizing the prices and the market participant behavior in that market. They assume rational market behavior, and then suddenly an optimization algorithm is then able to make those projections of future prices. And this is actually used in big trading rooms to trade power. On the opposite spectrum, you have long-term gas contracting or other power assets, which is often decades-long contracts. So now you're interested not in a day-ahead model, but in a model which spans actual decades. And there, the decision support question is much more important. And we're seeing this currently with the Russian-European pipeline, which is being built or not being completed. We don't know. But obviously, such a pipeline has a big and significant impact on gas prices in all regions in Europe. So you want to have a model which allows you to simulate those type of prices. So yes, we're using optimization technology to optimize these models, but the real interest of such an application is the simulation capability for those kind of market models. Next one is we're going back to an auto problem. So when you're buying a car, sometimes you don't have the financial strength to pay cash. So what you are interested in is probably getting a loan. And now this loan might be approved for you, but in certain situations, you actually get declined the first time round. What do I do then? Now, then I go to a different bank, and what this auto lender was interested in, no, they wanted to keep that customer as a potential customer. So they asked us to set up a little optimization, which runs in real time, and for those initially declined customers, we want to have 10, in this case, very profitable, approvable loans with alternative deal structures. So we might have changed the loan amount, we might have adjusted the term, we might have adjusted the repayment terms, whatever. Yeah? So, and this is the outcome of a real-time optimization. So we can still run this in an automated system. Key benefits are very much faster loan negotiations, with significant savings, much more transparency. You have lots less manual involvement because we could recover from an initial decline. And obviously, customers are much more happier if you approve than decline them. And this is now an application where you're combining the predictive modeling. We saw this in loan pricing. You again need to model the efficiency here in combination with real-time optimization, in combination with rule systems, which are about evaluating eligibility and other criteria. So this is in the sense of an enterprise AI solution. This is one of the most complete and very mature implementations. Next step is you've handed out those loans, and then very sadly, some of those customers actually can't pay back. Then you're having the collections challenge. So how do we deal with those customers? What are the treatments we can offer them? And this is collections optimizations. And if you do this right, so you act on an individual analysis of those customers and their challenges with the right action under optimized utilization of your resources, like your call center, then you actually can reduce your costs and improve customer satisfaction very significantly. And as you can see on this slide, there's pretty significant KPIs which have improved due to such a solution. One thing I want to also touch on is GDPR, which is big here in Europe. I'm based out of Munich. So when you are as a customer in these situations being treated by an automated decisioning system, you are allowed, or you can request an explanation how this decision has been reached. So if you now translate this into what we are doing here, so we are providing automated, optimized decisions. The why matters incredibly. So if we can't answer the why for this situation, we're suddenly not allowed to use optimization technology. FICO hosted a explainable machine learning challenge 2 years ago, and mathematical optimization technology was actually the winning technology to explain models or to provide highly interpretable models. So that's another application of optimization, really. And it matters in optimization. It's a key requirement, not only in these specific situations, but for every solution. Why is my production plan looking like this? Can you explain that? So it's important permanently. Same question, machine learning and artificial intelligence. The question of the why becomes more important. And just to split this up a little bit, it's not only the explainability, but in the best case, it's the interpretability. So I want a model where the user can actually see what's happening. And you might say in an optimization model, if you're an expert, it's interpretable to you or to me, but not to the broader spectrum of people. So what we can provide them is probably explanations. And same for machine learning. There's decision trees and other rather easy to interpret model, whereas a deep neural net, there's no way to understand what's going on except for providing explanations by running data through it. Another interesting combination of optimization with rules technology is in airlines. So when you think you want to plan a cruise schedule, you have a super thick book of regulations, how those crew, pilots and cabin are allowed to travel, how the trips can look like, maximum working hours as the probably most trivial example. And this is all formulated in rule systems. So we're using here the FICO rule system together with optimization technology to compute the best possible crew schedules. Southwest is a pretty significant FICO customer, so they're using optimization or FICO's optimization technology, not only for crew scheduling, but also for fuel and tankering optimization, for flight schedule planning. So this is just a super long list, but I wanted to point out this combination of rules and optimization technology. And then the final example is the is now a pure forecasting or machine learning use case, if you will. Yeah, so some users have very associated questions where optimization technology might not be yet their question, and we can still deploy this in our platform. And they basically, what they are doing, it's a big diagnostic medical practice. They have 10,000 employees. They have 240 service centers. And now their question is, which employees and how many employees do we need to deploy in each of those service centers? And they have built out predictive models to predict the need for each of those service centers for every day. And they're not using yet optimization to allocate those resources, but the first step is really how can our business use those predictive models, and what are the best models to use, and we are providing an analytic solution which can actually be used by business users to make those predictions in a much more accurate and in a much more accessible way. So this serves an example is all of those AI technologies, same way of taking analytic assets to business users might apply not only for optimization, but also just for machine learning, as in this case. And with that, that concludes my example section here. And just to give you a few more pointers, we have a community license, so you can use that. It comes with the solvers, the modeling, as well as the application capabilities around this. So really Solver, Moselle, Insight, and our workbench. Please try it out. We also have an academic partner program, which provides you with a full size version. I provide the link here, and if you denote that you're a combinatorial optimization at work participant, we will set you up with a full version of all of our software. And then finally, I haven't shown you any of this in action. We have tons of tutorials. Again, links are here, will be provided to you as well. And if you're a Python user, I had a recommendation earlier in this presentation. So thanks again for your attendance. I hope it was kind of interesting to see the little bit broader context, how we see the world of optimization in the broader context of enterprise AI solutions. And if you have any questions, we've set up Q&A sessions. I'm eager to talk to you there. Thank you very much.